They also deal with the coupling to energy-consuming infrastructures, especially electric transportation, which we'll be talking about today, and buildings and industry. Registration is open for the upcoming workshop, and everyone is invited to attend. ESIG is a very unique organization, and I don't think you'll find anything quite like it anywhere else in the world. If you're new to ESIG, I strongly encourage you to follow up with us if you like what you hear, and I think you'll be pleasantly surprised. You can find us at www.esig.energy, as well as on LinkedIn, Facebook, and Twitter. Okay, just a few logistical matters before we get started. First of all, phones will be muted for the duration of the webinar to avoid unnecessary distractions. So please use the question and answer box on the lower right side of your screen to submit questions, and we'll save 10 minutes or so at the end for the Q&A. We plan to wrap it up at the top of the hour, and an email with a link will be provided once the presentation and the audio file have been posted. We also plan to provide short responses to unanswered questions after the webinar, so don't be afraid to use the Q&A box. Okay, so today's webinar topic is electric transport synergy with renewables. I see a lot of interest in electric transportation out there, and I also see a lot of questions about just how quickly it's going to happen. At the end of the webinar today, my hope is that everyone will be a little better informed and have a little better sense of the opportunity before us and the challenges with electric transportation and renewables. The webinar will feature Johan Driesen, who's a full professor at KU Leuven in Belgium and teaches power electronics, renewable energy, electric drives, and electromobility. He conducts research on distributed energy resources, including renewable energy systems, and applications of power electronics, which play a significant role in renewable energy and electric vehicles. Johan is also involved with Energyville, the European research collaboration specializing in energy and smart cities and buildings, and is the program director of the International Master's Programs in Energy at KU Leuven. I feel very fortunate to have Johan here with us today. On a personal note, as I've gotten in the habit of doing, I took a look on LinkedIn last night and I found out that Johan and I had 15 shared connections. And I think what that means is that I need to get more plugged into electric transportation. Johan has participated in several ESIG events in the past year, and I'm looking forward to what he has to say on the webinar today. The webinar will discuss different options for making the transition to sustainable transport from an energy system perspective. It will compare electrical energy options with other alternatives for mobility and will highlight the topic of smart charging. Options for shipping and air travel will be discussed as well. So without any further ado, let's go ahead and get started. And Johan, I'll now turn it over to you.
Okay, thank you for the introduction, Charlie. Good evening for those who are in my time zone, good morning for those in other time zones, and good afternoon for those I've forgotten. Now, as Charlie said, I will be talking about the link between transport, and more in particular electric transport, and the rest of the energy system in which we see much more renewables. But first, we'll go through some fuel options. What are the ways we try to make our transportation system clean, and mainly clean from the point of view of CO2 emissions, but also much more healthy. And that's mainly in terms of lower NOx and particle exhaust. And I will discuss this to start with the typical cars and vans and buses, but later on I will also be talking about the bigger types of transport like ships and airplanes. And along the way, I will discuss how these interact mainly with the electrical system. Now, as you all know, there's an energy transition happening in a lot of countries around the globe. And you always see these typical pictures of the new energy system, and mainly an electrically driven energy system with solar modules in there, with wind turbines, offshore wind turbines even, some classical power plants used in a different way. But also, always you see more and more vehicles appearing on pictures like this. So clearly it's understood that there must be an interaction between these new types of cars and the energy system. What kind of interaction? That was left in the open for a long time. Will we go to electric cars, hydrogen cars, or will we make synthetic fuels? Well, it will probably be a mix of all those in different types of transportation, which I will try to explain to you in this hour. But let's get started first with the first type of clean fuel that was ever considered, because we want to get away from fossil fuels because of the CO2 emission that is linked to that, so the carbon content, and maybe replace them by biofuels, which are actually chemically identical, but they are based on plants, so a short carbon cycle. That was an idea that kept flying for a long time, but there are some problems with that, because we need to, of course, grow a lot of plants to convert them into biofuel products. And there it's clear that this may interact with the food supply system, with the food chain, and there will be land competition. Of course, we can grow newer types of biofuels which are interacting less with the food chain, but still you feel that there will always be competition for land. And also, in recent years, it became more and more clear that to grow big amounts of plants for biofuels, you will also see interactions with the CO2 produced by, for instance, the fertilizers. So in the end, it is officially a renewable, but biofuel is going more and more towards the background and not really considered a widely interesting option anymore. And by the way, if you switch to biodiesel or so, you're not going to solve the health-related problems like particles and NOx emissions. So the next candidate was natural gas. Of course, this is a fossil fuel. We start from methane, change the engines a little bit, and you get a very clean burning with almost no particles and almost no NOx if you tune them very well. And in a lot of countries, this is very popular for heavy traffic, like public buses. For instance, you see these a lot in Europe and some American cities. But of course, this solves the health problem, but not so much the carbon emission problem, because we still emit CO2 emissions, although be it much less, at least a factor 3 to 4 compared to classical diesel and gasoline fuel options. So, well to wheel, we are doing a little bit better here, but we are not there yet. But you may wonder, is this the best way to use the natural gas? Well, actually, surprisingly, these days, when we can also consider electrical vehicles as an option that is realistic, you may consider to use that natural gas to make electricity. And then it becomes interesting to check the whole chain, well to wheel, as we call it, in case of transportation. And we can compare, for instance, the top line that you see. There we use natural gas. We compress it to the right pressure level and put it into the car, and we drive with it with relatively low efficiencies. But these are efficiencies which are normal for combustion engines, for reciprocating engines. So in the end, you have a well-to-wheel efficiency between 10–20%. Now, these days, we can convert natural gas also to electricity by using combined cycle power plants. There's, of course, a little bit of transmission and distribution losses along the way, and we can put that electricity then into an electric vehicle with highly efficient charging. So this is power electronics. Efficiencies are always way in the 90s there. That's no problem. And in the end, if you drive, this is also extremely efficient because there's no thermodynamics involved. This is pure electromagnetics. So efficiencies of drive systems can be very high. So in the end, if you would use your natural gas to power an electric vehicle, we have the double amount of well-to-wheel efficiency compared to natural gas vehicles. So you see, even if you are still consider using some fossil fuels as a transition, moving as quickly as possible to electric vehicles is a very interesting option anyhow. But where's the hydrogen? Because for a long time, talking about clean cars meant talking about hydrogen vehicles. Now, a hydrogen vehicle, honestly, is an electrical vehicle. You just make electricity on board by using a fuel cell based upon hydrogen that you put in a tank in the vehicle. So in fact, this is what we call an electric series hybrid car. And the exhaust is, of course, clean, because if you burn hydrogen, you get water as an exhaust. Now, the hydrogen itself is not easy to make, although in some chemical processes it may be a cheap byproduct, but watch out, these chemical processes may produce also a lot of CO2 emissions directly or indirectly. So you have to come up with clean hydrogen based upon renewables. So you need clean electricity to make green hydrogen to be put in cars. So that means you need electricity somewhere along the way to make hydrogen as an intermediate fuel to drive your car in the end, which is also an electric car. And then you may want to consider also the well-to-wheel efficiency. And that is what I will try to show on this slide. If you use electricity anyhow, again, we can put electricity directly into the lithium batteries in a car and start driving, very high efficiency. Alternatively, we can use that electricity to drive an electrolysis process, have some compression along the distribution chain. That's another set of losses. And in the end, you're going to convert it back into electricity in a fuel cell. Now, fuel cells, there's a big range of efficiencies, but honestly, you will never reach the high efficiencies of direct electricity conversion. So in the end, and this is just one example, there are several studies and several analyses of well-to-wheel that show this. In the end, you can use with the same electricity to start from, you can drive 3 to 4 times further with a battery car these days than with a hydrogen car. Of course, hydrogen, we should not forget, we should not completely throw them from the table immediately, these kind of fuels, because the big advantage is that hydrogen can be put in a tank under high pressure, and you can take a lot of hydrogen or another type of gaseous fuel along with you. So if hydrogen still has a future, it's probably in long-range transportation where you have to cover large distances, or as a kind of storage for energy, and for energy that you want to put aside for a very long time. So you see, by the way, another way of comparing the performance of different types of vehicles. So if you start from the same amount of primary energy, well-to-wheel, and you compare, for instance, hybrid cars, diesel cars, hydrogen cars, electric cars, these days it's clear that the electric cars are winning with at least a factor of 2 to 3 compared to the other options if you do the full well-to-wheel analysis. But how are we going to use the hydrogen if we would use it still for long-range transportation? Well, then we have to consider power-to-gas processes. We are going to make synthetic fuels in the end. And synthetic fuels, excuse me, with synthetic fuels, we are going to try to use excess renewable electricity to generate and store hydrogen or process it further to other gaseous or liquid fuels. But for that, you need a lot of chemistry. And that is illustrated in the next picture. Because if we start from electricity, we use electrolysis to generate hydrogen. You can combine this with CO2. You can capture this from the air if you want. This is like a negative emission. You can combine that to a methanation process. You've got natural gas, clean natural gas left. You can store that even, or put it in a natural gas system as a kind of clean fuel, so a synthetic fuel. So for a long time, some car companies thought that this would be the ultimate clean vehicle, because they didn't believe in what was possible with batteries. Car companies like Audi invested a lot of research in power to gas, but in the end, it seems to be more interesting to use this as a kind of technique to do long-term storage for energy, or, of course, use these synthetic gaseous fuels for long-range transportation. I think of maybe ships or big trucks. But anyhow, this is another option that we will definitely need to consider. We should not throw away the natural gas system right away. It will be used probably for a long time with this technology to come. Now, do we always need the electrical route? Well, there are alternatives. You can also make a synthetic fuel directly from sunlight. But this is low TRL technology. This is possible in the research lab. You need alternative types of solar cells, not the ones producing electricity, but the ones with built-in catalysts. And they will, for instance, take water from the air, a little bit of moisture, and turn this into a hydrogen and release the oxygen. This is something that has been proven, as I said, on lab scale mainly. The efficiencies are still really, really low, but never say never. Maybe one day we are going to combine renewables making electricity with renewables making fuels. But for the moment, and definitely the coming years, maybe decades, the solar electric option to make these kind of fuels will definitely be the one that is the most profitable. Yeah. So these are solar fuels. So I can quickly conclude now that electricity-based transportation is probably the best. Yeah? It has a good performance, enormous traction, very good well-to-wheel performance, low noise, although some people consider that also as a problem, that it is too silent. We know how to produce these vehicles cheaply, and here I have to mention a study that was published actually last week. For a long time we said it will take some years before electrical cars will be as cheap as combustion vehicle based cars. Well, last week Bloomberg brought out a study that showed that we can maybe reach the break-even point by 2023 already, and that's mainly because of mass production and the crashing prices of the battery cells, which were always the most expensive components. Now, this is a very important date, 2023. Why? Because this means we are actually one leasing cycle away from actually having cheaper electric cars compared to combustion cars, if of course these studies are right. Now, of course, there are some points to discuss. I will talk about the charging problem in a moment. For a long time, the cars were a bit heavier, although if you look at lithium batteries, we still shrink them with a factor, with a decent factor. Some people predict we can shrink them further with a factor 4, so we can put in much more energy into the car, so range anxiety problems, they will disappear. The only problem that will remain is actually, are we going to have enough charging points in the right place? But I will discuss that in a moment. There's also a bit of discussion about whether with the life cycle energy or the pollutants that get involved in battery production are not such a big problem. But as far as most studies can predict, this is something that is under control. These materials are recycled, and there is for instance, a material that is debated a lot is the use of cobalt. Well, we know for the future batteries how to get rid of the cobalt or how to minimize the use of it so that we can just use a recycled supply for this. So actually it looks pretty good for electric vehicle. But a bit on the side, something that maybe some of you are not aware of, actually electric vehicles are older than combustion vehicles. At the end of the 19th century, these were the promising vehicles. Very easy to drive, easy to start, clean. They were considered cleaner than the common form of transportation in those days, which were the horses. And I leave it up to your imagination what they mean with cleaner exhausts then. But also in those days, they had to think about charging and where to put charging stations in the then developing electrical grid. So you see, after 1 century, we are still fighting with the same problems. But modern day electrical cars, they look a little bit nicer. They are actually very simple. And here you see basically what is a Tesla. I always describe this to my students as this is a skateboard made out of battery packs. with a very simple electrical drive, the very dense power electronics, and on top of the skateboard, they just put a fancy body with a color and kind of seats that you like. So in the end, this shows that making an electrical car is actually a quite simple process. And honestly, I also have some mechanical engineers who follow my courses on this, and they don't like this. So, but this shows that there's potential to make electrical cars cheaper in the end, if we can bring down the battery prices, but that seems to be happening in practice. A cheaper type of electrical car, which is very popular, is for instance the Nissan Leaf, and there we see a similar design with batteries in a kind of skateboard structure under the floor. But why do I show this Nissan Leaf? Well, the Nissan Leaf was the first car that had a fast charging plug, actually. If you look at the picture on the bottom right, you see there is a bigger plug there. That is a DC plug, a CHAdeMO plug, which allows to charge at more than 60 kilowatts. So a relatively high rate, which would allow you to recharge your car in probably less than an hour. Of course, we still have to compare this to being in a fueling station for just a few minutes. So we are not there yet, but this is just a start. The new standards that are now being rolled out with new charging stations being deployed, they go to several hundreds of kilowatts. And honestly, you have to ask yourself, do you really need these fast charging stations all the time? Because in the end, a car is just a fancy object that you buy to be parked most of the time. So honestly, there's lots of time to recharge slowly as well. But I will come back to that in a moment. Now, if you look at the current market in Europe and US, there's also a lot of plug-in hybrid electrical vehicles on the market. And these are considered now as a transition technology towards full electric driving. Yeah, these are vehicles that can drive a bit further if the battery is depleted, so they can use a standard fuel then. But this leads to quite heavy vehicles, which are not that cheap. So it's expected that probably a decade from now, they will, most of them will disappear again from the market. But in the meantime, it helps us to get used to plugging in the charging cable. But something that should not be forgotten is what also happens in the bigger types of vehicles. It's not all about Teslas, this story. Electric buses are changing extremely quickly for the moment. You see here some examples of an American bus type, the Proterra. There's also on the left side is a European-built bus, a Volvo with a flash charging station, or what they call also an opportunity charger. And you see a similar type of charging at the bottom picture at the Schiphol airport, where all the passengers are brought to the planes with electric buses. And they have very small batteries, and they are recharged very quickly to go for the next service. So this also brings another type of interaction with the electricity system. If we roll out public transport like this, this means we have extremely high power chargers, and we are talking here of chargers up to 0.5 megawatt, which are used for just a few minutes, and then it's waiting until the next bus will come. That could be 10 minutes later or so, but you will have a very peaky load at high power, which needs to be integrated in the electricity system. Now, this is what we call opportunity charging or flash charging. I have to say that these days there's also buses on the market which are fully electric, who can do with a charge overnight and run all day. And there are cities in China with 20 million inhabitants where they've changed all the buses already to these electric plug-in buses. So never say never, and never say that it can't be done. And what about goods transportation? Probably most people know about these Tesla trucks, and they are very spectacular. They accelerate fine. It's one of the toys of Elon Musk's. And when it was brought out, Mercedes was also very quickly to show that they also have a prototype. So they clearly had it somewhere on the shelf until there was somebody interested. But I think what is personally for me a more interesting story of transition in electrical transport is the a Deutsche Post vehicle you see on the upper left. Actually, this is the new vehicle that they use at the German mail services, and this is a very big company, Deutsche Post. They actually own DHL, the international transportation company as well. They actually launched a tender for electric trucks for their mail deliveries, and no company could offer the kind of electric van that they wanted, a very simple, low weight van for use in the city. No company was able to offer it, or maybe we should think wanted to offer it. But the Germans said, okay, then we do it ourselves. They built their own mail vehicles. Okay, imagine a US Postal all of a sudden turning into a vehicle builder. But the Germans, they did, and now they are selling this vehicle to other countries as well. So they are selling electric cars next to delivering mail these days. And now all of a sudden, the car manufacturers are very interested to also follow this. But sometimes you see interesting evolutions in the market like this. But in the end, we have to consider this interaction with the electricity system. And because battery vehicles, they may have a very big impact on the distribution system. Think of these buses that need flash charging of 0.5 megawatt somewhere in the middle of the city. So you need connections that can deliver this. And we may think of how these charging vehicles will interact with other trends that we see in the built environment, like introduction of more photovoltaics and the introduction of more static battery systems for local balancing or to make local energy communities. So the question is, could or should these vehicles, these charging vehicles, also be turned in some kind of flexible loads? Because I cannot repeat it more than enough, actually vehicles are standing still most of the time. Most vehicles are used for just a few % of the time that you own them. So it's a fantastic flexible load if you have the right kind of charging point and if your vehicle is in the right location. And some people are considering then to go a step further and also consider this a set of batteries that you can discharge also into the grid to offer ancillary services like reserves or even backup power, emergency power, and so on. Now that is for the directly charging battery vehicle. Of course, if we consider the gas route for the long-range transportation, there are several buffers built in, and this should be considered as a large, maybe shiftable industrial load. So this will also fit nicely with renewables. So, but a big question is still, where are we going to charge? A lot of people have a driveway or a garage, and that could be the home base where you install a relatively low power charger, and overnight your vehicle can charge. Yeah. But of course, at night there is no sunshine in case you have photovoltaic panels. So we have a perfect mismatch there. But a lot of vehicles will also be, especially more company vehicles, professional vehicles, they will be charged on the parkings of offices somewhere throughout the day. And then there's still the question, what if you go to pay a visit to a city or another place, or you go to big shopping malls or points of interest? You also have to think of maybe offering charging there. And there could be even there could be some interesting business cases behind it. For instance, some big shopping chain, think of IKEA. In some countries, they offer free electricity if you come shopping with them. So you see here, we have to think of also the business models. How will this affect the local electricity system? And this is not a minor change. You can easily prove that if you add an electric vehicle to a family home, actually the electricity consumption on an annual basis more or less doubles in most countries. So there is a very big impact, but on a very local scale. And the risk is that if you do uncoordinated charging, We all drivers are social animals. We all go to work at the same time, come home at the same time, and we plug in at the same time. So if you just plug in and let the car charge, you end up with having big peaks in the evening, when we get other consumption peaks from the HVAC, the cooking, the lighting, etc. So we end up with a very big consumption peak in the evening that may stress the local distribution feeder a lot. We've made some studies for Belgium, but also other European countries. This was studied, and we all came to the conclusion that roughly if 1 in 3 vehicles would be electric, that's sort of the limit what you can handle. If we have more than 1 in 3 vehicles in the street on average that will turn electric and there's uncoordinated charging, you tend to overload the transformers and mess up the voltage profiles too much. So that is on the distribution level. Now, what about the power plants? Because sometimes you can read articles that say, yeah, if we all are going to drive electric, we need to build nuclear, or we need to build coal, and then we are saving no CO2 emissions. Honestly, if you study this carefully, you make good simulations and models about it, honestly, in most countries, you will hardly see the difference. There is, of course, more electricity consumption, that's without doubt, but it can be spread out and it will be matched, if everything is, of course, implemented correctly, with the new types of production like renewables in a relatively easy way. Now, what about transmission level? At transmission level, they hardly see the presence of electric vehicles because they're spread out over the whole country. And especially if you are using coordinated charging and you mainly charge at night, it may help to fill in the low demand that you typically have later in the night. This is also an effect that transmission system operators will like, but of course you need to have some coordination and even new types of business models to make this happen. But again, the biggest problem is actually at distribution level, where we risk having big peaks, especially in the beginning of the evening, and high loading throughout the night, and even in some cases there's a risk of increasing unbalance on the voltage system. So this is very similar to also problems that you see if you would massively roll out heat pumps to heat or cool houses. But there, of course, this load is spread out over a longer period during the day. So we need coordinated charging. And then the next problem pops up. What about the interaction with the photovoltaics on the buildings? There we have indeed a big problem, because typically during the day when there's lots of sunshine and electricity can be produced, the vehicles are not at home, they are not charging, or at least not charging in the place where you produce your solar electricity if you do this at home. So we have there the perfect mismatch, but their storage technology may help. You see in a lot of countries that there's clear trend towards selling photovoltaic systems together with battery storage, so that you can implement the right kind of flexibility, so that you just shift your consumption and your production of the electricity a few hours apart from each other with some local storage that is complementing the photovoltaic production. And if we are using the vehicles as a flexible load in the end, because again, they're parked for a lot of time, either at work or in parking lots or at home, the next step is to consider these vehicles also as a kind of flexible battery. And that is a very interesting thought. They call this the vehicle-to-grid model. And you can discharge, in theory, if you have the right kind of control, you can discharge your battery back into the grid. And the latest charging protocols like CHAdeMO or the new CCS protocols, it's foreseen already that you can give the right kind of commands and discharge your vehicle, your battery back into the grid, for instance, for reserve power or backup power. Now, for a very long time, the comment on this idea was, okay, but then you're doing another set of cycles, discharging and charging cycles, and the battery will die slowly, and you're not making enough money with this to compensate. Well, honestly, this is changing as well. These days, the batteries that are being used in electric vehicles, they can do so many cycles, actually too many cycles, compared to what you actually need if you keep your vehicle in your possession and drive around for a few years. And this is something that will not go unnoticed. Actually, electric vehicles, they are wearing out almost not. They're almost not wearing out. There are no parts that you need to replace, like spark plugs or belts, etc. There's almost no maintenance to be done. Not even the brake discs are wearing out because you do regenerative braking. And it's expected that electrical cars will be in use for a much longer time compared to combustion vehicles. So in the end, why am I telling you this? It looks like with the new type of batteries, you won't kill your asset so quickly if you would put it in a vehicle to grid scheme. Now, of course, if you want to implement this needs also some smart regulation and also some very good planning and IT to find out where the vehicles are and whether you can use them, and then also come up with a nice business model to compensate for these delivered services. Now, this is one example of how the cars are probably going to change the electrical system. But you can think further. Is the transportation itself not going through a major change in the future? Because we are still used to think of either we have our own personal vehicles or we take public transportation, and like those electric buses or even trams and subways. But if you look at the private vehicle ownership, in a lot of countries, this is clearly on its way down. Car ownership is not the first choice of many young people anymore. They use shared vehicles. Sorry, they use shared vehicles, or they only rent vehicles according to their need at that moment. And this trend is part of the trend towards mobility as a service. So that means for the vehicles themselves, these shared cars, they are actually used much better, much more than the privately owned vehicles. They completely wear out in 2-3 years because they are driving so much. But this has a big consequence also for the charging, because there's less time for them to recharge. So probably this will indirectly also cause a higher need for faster charging modes as well. So, and in the end, maybe the ultimate dream of some people, what if we are going to end up with the self-driving cars? Well, then probably the charging problem is completely solved, because in the end, the car will drive itself to the open spot, to the free charging point that is available, and charge there without it hindering your daily habits. But if this is possible, you may think further ahead, and we may even see these self-driving cars being ordered by the grid operators to be used in vehicle-to-grid, and like a kind of battery-on-demand system. But this is just thinking further ahead. Who knows what these technologies will bring us further. But okay, that was for the typical technologies of transportation on 4 wheels. But if you look at the amount of energy that is being used for transportation, actually a big part of the energy for transportation goes to big modes of transport like ships or airplanes. And we also have to think whether we can turn these into some kind of sustainable form of transport. In the end, maybe also things like rockets should be changed. But for that, we will need synthetic fuels. We will not discuss these further. Now, what about the ships? Well, honestly, most modern ships that are being built and are being used for the moment, they are already electrical driven. The propellers are using what is called pod drives, and that is something that you see on these pictures. You see some ferries here, and instead of the typical rudder at the bottom of and the back of the ship, we have there a kind of torpedo-like structure containing an electric motor with a directly connected propeller. And this system can be turned 360 degrees around. So these days, with some ships, it's easier to park them than with your own cars. They can just move sideways if necessary with these pod drives and bow thrusters. So it is possible to run them electrically. It's just if you have to cover a very big distance, you cannot take enough batteries on board to cover this. This will probably always be a problem. So that's why we need the typical fuels, maybe hydrogen or maybe a further developed fuel. For instance, for the moment, it is considered to either use a gaseous fuel like LNG or even ammonia, because ammonia doesn't contain any carbon at all anymore, as then a transportation fuel for long-range shipping. But for short-range shipping, like the ones you see at the bottom, these are typical ferries. This is a picture actually from Norway. In Norway, they are turning all the existing ferries into electric ones to cross the fjords. The picture at the bottom right is actually a kind of drone ship that is used for short-range transportation of containers. This is currently being tested between the harbors of Rotterdam and Antwerp, so that's roughly covering only 100 kilometers. So for ships, we can handle. But what about flying? Because in some doom scenarios about the climate, people are thinking that we will have to stop going on holiday with an airplane because there's no alternative to that. Well, wait a moment. Actually, a lot of airplanes these days are also hybrids. They also use a lot of electrical technology, mainly because of the weight reduction that you can get out of this. Now, historically, the airline industry didn't like this because they only believe in mechanical technologies because they are reliable. They didn't trust electrical technologies, but they had to change their mind for these new types of airplanes like the Dreamliners, the Airbus 350 or 380, just to save weight. And also they use onboard batteries to balance out the local consumption, and in that way they can make the engines more efficient because they won't be using bleed air anymore. And other experiments are already being done with electric taxiing to save fuel on the ground. But then the ultimate question is, can we fly electrically? Well, yes, we can these days. The pictures that I'm showing you here actually show that it is almost possible. Actually, let's start with the picture at the bottom left one. This is an electric airplane, a single-seater airplane. It can cover a few hundred kilometers. And then they use electrically driven propellers. So if you use propellers, that means you cannot go to extremely high speeds, but for short-range flying, this is more than enough. And also here we saw the same trend as well as with the postal vehicle that I told you about before. Here actually companies like Siemens insisted on building such airplanes because they believed in it, and the traditional companies like Boeing and Airbus, they didn't. But in the end, definitely Airbus is changing its mind, and they are now also developing electrical prototypes. But if you look at what is happening for the bigger jetliners, for instance, on top you see an EasyJet plane. This is not existing yet, but EasyJet is themselves in projects with companies like Wright Electric to also try to develop a narrow body plane for passenger transportation on relatively short distances. Think of 1,000 kilometers. And they use electrical propellers and streamline tubes built into the wing. And these planes, another reason why they are sought after is because they will be much more silent than the current planes. So maybe it will be possible to fly through the night in the busy airports where the current types of airplanes are not allowed. But honestly, the most popular type of electric airplane is the drone. There's a lot of interest in drones. Some people think that Amazon will drop packages in your garden with drones. I don't know if that will be happening, but anyhow, you see a lot of experiments, and what seems to be happening for the moment is that drone types, like the one you see on the top right, they are slowly pushing helicopters out of the market. And maybe one day these kind of drones will be used as a kind of three-dimensional Uber services that will bring you throughout a city. This is actually being tested for the moment. This is not a drawing. This is an actual picture of a test being conducted as we speak in Dubai with this engine called a Volocopter. So you see, in the end, I'm actually quite optimistic about the transition that is happening in the transportation sector. Yes, we will have to think about how to interact this well into the energy system. There will definitely be, on the short term, issues and problems to solve, especially if we are massively going to roll out battery vehicles. So we need to integrate them, and the bottleneck is there clearly the distribution grid. But if you do this well, this will be working nicely together with all those new renewables that we are going to put in the system together with new types of storage technologies. And also for longer range transportation, we've got these new synthetic fuel types, which are also electrically produced. They will also help us to balance the system further. Okay, I'm going to leave it here. I thank you for your attention.
Okay, Johan, thank you very much for a very thoughtful and thought-provoking presentation. Let me remind folks that we have the Q&A box in the lower right-hand corner. We have a couple questions there now. I have a few of my own, but let's go ahead and take a few questions, Johan. One very straightforward one, I guess, just what are your thoughts on the role of hydrogen in long-distance trucking? I know you mentioned that earlier in the presentation and talked a little bit about competition from between electric and hydrogen for long-distance trucking.
Yeah, for long-distance trucking, first of all, you have to consider, do we need long-distance trucking? Because that competes actually with railway transportation. And also there, in a lot of countries, there's a lot of evolution there as well. Maybe we will be using things like Hyperloop, although that's a very exotic technology still. But definitely for the big trucks, long range, several thousand kilometers of distance that they will have to cover, there we have to think of some kind of synthetic fuel. It could be hydrogen, but things like CNG or even ammonia are considered there as an easier to use alternative, because hydrogen, whether you like it or not, you still cannot go around some safety issues that go along with handling hydrogen and refueling, etc. But definitely from a point of view of energy efficiency, we have to do it as much as possible directly electrically, so with a train or so. And if there is absolutely no other option, then we still have these synthetic fuels, and that could be hydrogen.
Okay. Let me expand on another question. The question has to do with how much the electric load will go up if all transportation is electric. I'd like to expand that just a little bit to get your view on the rate of change of adoption of electric vehicles. Do you see a time when there's a tipping point, or when a majority or 90% will be electric? And do you see any parallel planning or thinking going on about the expansion of the renewable resources, wind and solar particularly, to be able to kind of stay in step with the growing electric load from transportation?
Okay. Now, first of all, the growing amount of electrical transportation, that depends a lot on the country you look at. In some countries, we see it's happening slow. In others, it's going extremely fast. Like think of countries like Norway. Of course, this is also linked to certain incentives from the government to make the transition to this type of vehicles. But definitely, we cannot go around that tipping point that will happen in probably 4 to 5 years from now, when electrical cars will be very likely a cheaper technology if you just look at the acquisition cost compared to the fuel-based vehicles. So it can go very rapidly. But then the question is, will we ever reach 100% change? There's a lot of debate about that, and if you look at scenarios like from International Energy Agency, they're always very pessimistic. They hardly see, they in their long-term scenarios, they still have half of the vehicles being classical vehicles, but then with biofuels. But honestly, every time they bring out new scenarios, this number is shrinking. So it looks like we will go to a very high amount of electrical vehicles in probably 2 decades from now. And then the question is, what about the extra electricity production? Because I said, if you just have a few vehicles, you will hardly notice that in a power system. Now, if we have several tens of percents of vehicles, it depends a bit on the electricity system that is already present in a country, but then you have to produce, assuming the rest of the consumption won't change, you have to produce several percent to several 10% of electricity. So definitely we have to keep that in mind if we make the future planning scenarios. Now, whether renewables will keep up or not, the classical power plants, they are all aging, they need to be replaced, and in a lot of countries the cheapest option to replace them is for the moment renewables, but that is definitely the case for the first part of this century. But what about the second part of the century, when we have gone through several cycles of this transportation system changes, and also when all the classical power plants will be gone? The question is, how will we complement the renewables? And then it depends on where you are on the world. According to some, we will still need some kind of nuclear. There are several options open there. Or we have to come up with some kind of cleaner gas technologies. But that is more long-term. That if you compare it to the typical lifetime expectancy of a car, which is a bit over 8 years typically, we have to first think on changing the first set of cars in the first 2-3 generations to come from now.
So stay tuned for further developments.
Yeah, definitely.
Yeah. Okay.
And don't underestimate this public transportation. There it is going extremely rapidly for the moment.
Okay, a question on the challenges. What are the most important pressing challenges to integrating large amounts of electric vehicles into the power system?
Yeah, the bottleneck is the distribution system, but also where to put the chargers. Because we will do a lot of overnight home charging, but especially in cities, people do not always have a garage or a driveway. I can speak for myself. I live in the middle of the city, and I park my car somewhere in the street. So I cannot just run a cable from my house to my car. That's impossible. So people like me, we will have to rely upon some kind of public charging, and there definitely fast charging will still be something that is that needs to be offered in the future. So the two bottlenecks are making sure the distribution grid will survive it, and also the placement of the right kind of charging in the right place.
Okay, and speaking of charging, you mentioned inductive coupling as being one of the options under development. What's your thinking about how much change will be impacted by the ability of inductive coupling, where you can just drive up to a charging station and not have to plug anything in, versus searching for a place where you can physically plug in?
Yeah, inductive coupling is one way of charging. Of course, there's a bit of penalty. There's always a bit more losses, but that's relatively limited because there are some experiments happening already with inductive coupling. You just have to park over your vehicle, over the charging coil as well positioned as possible. But with a self-driving car, that's no problem at all. I have a car that parks itself if I want, and that's very accurate. But the question is, are we going to break open all parking spots and put coils under them? I don't know. For the moment, one of the reasons why some people think we will go to a lot of inductive coupling is that if you look at plug-in hybrid vehicles, in the beginning, the owners, they plug in wherever they can, and after a few months, they don't plug in anymore, but that's just because of laziness. There are people who don't like the handling of the cable because they think the cables get dirty, but honestly, if you have to refuel a diesel car, that's not really a clean job either. So, yeah, will this be used in the future, inductive charging? I leave it open, maybe in some cases, but honestly, the ease of plugging in a cable, yeah, it's not that complicated. People will get used to it, and definitely if you go to higher powers, then we definitely have limits. Maybe a few tens of kilowatts is possible with inductive coupling, but if you need more surface, and your car is actually too small.
Okay, and speaking of the fast charging, there's always a question about the impact of the fast charging on the battery life. What's the current thinking there?
Yeah, well, if you would be fast charging all the time, it's clear that your battery life will be shorter. So that's why it's advisable to only use high power charging when it's really necessary. But that is with the current cars that are on the market. If you look at newer types of batteries that are about to be put in cars, they can handle extremely high powers without a lot of problems. Just have to make sure you implement the cooling correctly. And there is a very limited impact on the lifetime expectancy. And I think these buses, these electric buses with flash charging, they are actually showing that you can push this very far already now.
Okay, I think we've got time for one more question. It's another integration-related question asking about the greatest opportunities in power system operation due to the presence of a large number of electric vehicles. What additional flexibility or benefits do you get there?
Yeah, that is indeed. Depends a bit on how the vehicles are used, where you assume they are plugged in, because of course they need to be plugged in somehow. But if you there's a lot of potential that you can unlock. Think of just vehicles being parked on parking lots when everybody is at work during the day. There's a lot of batteries out there that can be used to balance renewables, but it's mainly the bottleneck is there. The regulation has to allow it. You have to find a good business model. Does it still fit with the idea of private car ownership? What about the metering that is linked to that? So technologically, there's a lot possible, but I think the main bottleneck will be their regulation in the end.
Okay. Maybe time for one last question that we have here on how second life use of retired mobile batteries evolve. Any thoughts on that?
Okay. If you look at batteries, well, first of all, the concept end of life is very difficult to use. In terms of electric cars, if you see the cars that are being scrapped for the moment, like the first generation of Nissan Leafs, maybe some very early Teslas, the batteries that come out, they still have roughly 80% of the original capacity, if not more. So they are definitely still usable. And we see now, I think since last year, you can buy the first second life battery packs as a much cheaper alternative for newly built battery packs. And they're being sold for instance, solar balancing with relatively smooth cycles. So you won't stress the batteries a lot, and they can definitely be used for a lot of years. So this is just one of the steps in the recycling oriented economy that already exists around batteries. So I think definitely there's a big future for this kind of recycled batteries. And this will go hand in hand with also the smarter battery management systems that are being used these days. The past battery management just meant a sort of estimator of the state of charge. But these days, battery management systems, they keep a whole history of what you did with the car, whether it was healthy. They try to estimate the state of health and expected lifetime. With all that data, you can put a very nice value on batteries that you want to recycle. So it definitely looks like the resale value of an electric car will be on the relatively high side in the future.
Okay, thank you, Johan. We really are at the top of the hour now, so we're going to have to wrap it up. As I mentioned earlier, An email will go out once the presentation and the audio file have been posted, and we'll also be posting the responses to any unanswered questions once they're ready, but I think we've gotten through all the questions. I really appreciate everyone's engagement. Look forward to seeing you at our next webinar sometime during the week of May 20th. The webinar will feature the topic of the interaction between transmission and distribution planning with DER deployment. It'll be presented by Eamon Lanoy and Jens Bomer of EPRI. Very timely topic today on the international scene, given the proliferation of DER on the distribution system and its impact on transmission. So I hope you'll be able to join us. Further information on all of our webinars and events can be found on the website at www.esig.energy under events and in our newsletters and informational emails. And Johan, I want to thank you again for this very timely and informative webinar, and thank all of you for your participation. We look forward to seeing many of you at the Forecasting and Markets Workshop in Denver in June, or next month with Eamon and Jens on the webinar. And in the meantime, everyone take care, and thanks again for your participation.